Hello viewers, you're welcome once again to Taxonomy Online Mathematics, question number 27, upward of the NECO 2023 objective test question paper. So in an examination, a candidate was asked to draw the graph of y equals to x squared plus x minus 27, which is a quadratic graph, and a linear graph on the same axis, such that their intersections will give the solution to the quadratic equation x squared plus 5x minus 29 equals 0, which is also another quadratic equation. What is the equation of the linear graph? We know when we construct or plot linear graph and quadratic graph on the same axis, their point of intersection is the solving of the two equations at the same time. Let me say simultaneously. Since y will be equals to, just like we are seeing here, the quadratic equation, the linear equation is also y equals to mx plus what? C. So we are going to say that since y is equal to this and y equals to this, we equate the two right hand side and solve it. And when we solve this and this particular one, it will give rise to a new quadratic equation without the y. You are seeing that if this is equal to this, shifting all the term from here to this side, you'll be left with equals to 0. And that's what you are seeing here. So simply means that if this plus this gives me this, then it also means that if I subtract this from this, I should be getting back the linear graph. So what will I do? I have my y equals to x squared plus 6x minus 27 being the original. Then I am now going to subtract. This is having equals to 0, so I begin with 0 equals to x squared plus the 5x minus what? 29. So I perform a subtraction of this to get my linear graph. You know, y minus 0 will still be y. Then x squared minus s squared will be 0. 6x minus 5x will give you only x. Then minus 27 minus negative 29. That will become minus 27 plus 29. And that will give you a positive 2. So simply put, the linear graph or the linear equation that is marrying with this to give us this very quadratic equation will just be y equals to x plus 2. And on the possible answers, that will be E, the option E. Question 28. What must be added to 2y squared plus 7y to make it a perfect square? You know, we are looking for a perfect trinomial. So in this case, for us to be able to solve it, we can solve it in two ways. We know if we are having 2y squared plus 7y plus c, let's just say equals to 0 to make it a quadratic trinomial. We are looking for this constant. What value of this constant will be added to this to make it become a perfect trinomial? To make it a perfect trinomial, it also means that the whole of this, if you find the discriminant, you should get what? 0. If you find the discriminant of this very equation, it should be 0. That means that it will become a perfect square. And how do you find the discriminant? This is going to be b squared minus 4ac, where b is the 7, a is the 2, c is the same c we are having out there. So what do? It must be equal to 0. Okay. So b, which is now 7 squared minus 4, where is our a, into bracket 2 times what? C equals to 0. You know, this is going to be 49. So I have 49 equals to the whole of this is going there. That will be 8c. We divided by what? 8 by 8. C will just be 49 out of what? 8. So this is what, if it is added to this equation, it will give rise to this equation to become a perfect square. Good. Or we can also say that if I have y plus a all square, which is y squared, we have 2ay, that is twice of this, plus what? A squared. This is a perfect square. So this is what we can get if we get this. Good. It means this equation, as we are seeing there, 2y squared plus 7y plus c. We can compare, but you can see here has what? 1. Here is 2. So we divide by 2. So here I'll be having y squared plus 7 over 2y plus what? C out of what? 2. We know how we can compare. Knowing very well that this and this are the same, this and this are the same, and this are the same. So right here, your 2ay is the same as what? 7 over 2y. Where in this case, we can ignore the y since they are the same. So we pick the one that are not the same. So I am picking this to be equal to that. What do? I divide through by 2. So a will be equals to, division here will be multiplication. It will turn over. So I'll be having what? 7 out of 4. You see that? This is what we are having. A. And here, the a is what? Squared. Before this to be the same as this, we must square our a. And squaring the a will mean that 7 out of 4 all squared, which is 49 out of 4, 16. So this your a squared, which is here, is the same as what? C over 2. So now here I'll be saying that 49 over 16 equals to C out of what? 2. Cross multiplication, making that I'll be having 2 times 49 equals to 16 times what? C. Divided by 16. This will cancel. This will go here each time, right? So 49 out of 8 is the C that we are adding, the whole of this that we are adding to this expression to make it to become what? A perfect square. Will be 4 divided by what? 8. And that will be the option and this will be the option D on the question paper. So for the question 29, we are solving the equation simultaneously. I would like to use one of the methods I taught in one of the episodes, the Cramer's rule, the shortcut. So I'll be taking the diagonal this way by multiplication. That is 2 times what? Negative 5. That will be negative 10. In this case, I am looking for x since I'm using the coefficient of y. X equals to 2 times this minus 3 times what? Negative 4. That will be negative 12. Divided by still 2 times 2. That will be 4 minus 1 times 3. And that will be 3. This gives rise to negative 10 plus 12 out of 1. And that will be 2 divided by 1. So your x is just what? 2. So now we can substitute the x into the first equation. 2 plus 2y equals what? Negative 4. Can we subtract 2 from both sides? So 2y will be negative 4 minus 2. And that will be 2y equals to negative 6. Divide by 2 as the coefficient of y. Y will be equals to what? Negative 3. So it means that the value of x is 2. The value of y is what? Negative 3. That will be the option C on the question paper. Thank you for watching. Like, share, and comment. Bye-bye.